I am Imani Daniels, and this is my presentation on IMAP and DNS for my Cyber 4220 class. IMAP. IMAP is the Internet Message Access Protocol. IMAP is the protocol that gets incoming emails, stores emails on a server, and will allow the receiver to read or edit them. Utilizing IMAP will allow you to flag messages, save drafts, and this is also what will sync with client applications to update read versus unread emails. The proxy between the server and the client is where IMAP resides. When an incoming email has been sent to a server, that's what the receiver is reading off of. This indicates that the incoming email isn't specific to whichever device it was sent to, and instead means that the email can be pulled from the server on any device as long as it's authenticated to open the email client. Once someone decides to send an email, they then sign on to their email provider or client, and that client then connects the server using IMAP. This connection is created on a specific port, and any headers that the emails have are displayed by the client. When the receiver goes to click on an email, that's when the email is then automatically downloaded from the server. Attachments must be manually downloaded since they aren't automatically. IMAP is quicker at retrieving emails than other protocols like POP3. Emails stay on the server unless otherwise deleted. Client-server protocols tend to work between both browser and an API, or Application Programming Interface. APIs are placed at the base of the HTTP, which is then placed on top of TCP. This helps make sure that data packets are delivered correctly. Also like HTTP, IMAP works on top of TCP and can work with the different types of commands known as IMAP commands. IMAP commands tell or ask the servers for information. An example would be a tag followed by a command with arguments in between brackets. Accounts tend to be set up with IMAP so that no user input is required. However, if an email has been set up under POP3 protocol, this could cause difficulties with adding it to an IMAP protocol. Setting up or configuring an account with IMAP would require the names of your POP3 and SMTP server from the provider and then using this information in the client. For example, this configuration down here, you'd pull your IMAP server, imap.thenameofyourservice.com. POP3 server, you would do pop.thenameofyourservice.com. And then an SMTP server, you would do smtp.nameofservice.com. A key difference between IMAP and POP3 is that while POP3 will obtain an incoming email, IMAP is more like an email server that stores the email and can be accessed from any device or location in the email client. IMAP installation with Dovecot for Linux. Dovecot is a secure email delivery agent and supports the following mailbox formats: inbox or mail dir or mail directory. Installing the Dovecot server with either POP3 or IMAP functionality, you would run the following command, which is the sudo apt install dovecot imap dovecot pop3d. Dovecot has a multitude of other modules that are available to download that include mail filtering, full text search, and user directory. If you'd like to configure Dovecot, you edit the file, the pathway of where Dovecot's been configured or downloaded, and its configuration files, which would be in Dovecot conf. After the configuration of Dovecot, restart it to test whether your configurations have taken effect with the command sudo service dovecot restart. For IMAP, you would log in with the command telnet localhost imap2. Once you've got the OK that Dovecot is ready, you can check the default SSL certificate, which is the Secure Socket Layer certificate, by using the package SSL cert. To configure a firewall to allow access from another computer, connections have been allowed on certain ports. These ports include IMAP 143, IMAP S, which is on port 993, POP3, which is on port 110, and POP3S, which is on port 995. IMAP hardening. One way to harden IMAP is to create firewall rules that don't allow any direct access to IMAP servers to those who aren't authorized to be on them. This keeps people with a malicious intent out by letting people who need access to the server access. Another way is to use two-factor authentication when remotely accessing email servers. That way, users must provide two authentication methods instead of one. You can also alter the email rules to make it so that any unauthorized access to services are disabled. Another way is to use the zero trust model to restrict users from accessing IMAP services without any sort of multi-factor authentication. DNS. DNS, or the Domain Network System, creates host names that are readable instead of IP addresses. So these are the website names that you see instead of being the long number that you see. You can type both into a browser and either one would pull up the website that you're looking for, but these are easily readable and you easily know what you're going to. So the DNS system is what creates these. The DNS starts a request or a lookup using the host name, such as a website, for example, google.com or Facebook, or even Kennesaw is a host name. The DNS resolver then connects that host name to the IP address that it's associated with. It moves from the TLD DNS servers, which is the top level down DNS servers, to the server that hosts the website. Once the resolver gets the IP and other details, it can connect with the server using the IP address that it got. DNS installation. Using the ISS, or Internet Information Services for Windows, can allow you to add a website based on the DNS name. To do this, you want to create a folder that's going to host the website. On the server, press Start and type in Internet Information Services Manager Console. Under Sites, you want to click Add Website. Enter the site name and the physical path that you saved in the folder you originally created. Then you want to create a host name and press OK. Once the site is created, it is then accessible by URL. DNS hardening. DNS attacks can be a daunting experience to have. Here are some ways to prevent those attacks from happening and strengthen your DNS servers. You can look over any DNS zones you have. This means to check and make sure that any domain names or subdomains are running updated software. Anytime they aren't, they become susceptible to attacks. Another way is to halt any zone transfers. Typically, you would zone transfer when you want to query another DNS server. This can become an issue if someone were to initiate a zone transfer of your DNS server. To prevent this, limit which DNS servers can initiate a zone transfer. Lastly, you can disable your DNS recursion. This prevents any DNS poisoning attacks, which is when a spoofing attack happens while in the middle of providing information to a DNS server that wasn't a server from a secure DNS source. This also includes keeping your DNS servers up to date. Since you have created your own name, this helps with opening the possibility of configuring your own settings and seeing what works for you versus if you were using a provided DNS server. It's imperative that you keep them up to date so that people don't exploit bugs or vulnerabilities. You can also use an isolated DNS server where you use a dedicated server, and you can host web services. Having this separate from other application servers reduces the chance that it gets hit with any web or application-based attacks. You can also close any unneeded ports and filter all traffic through a firewall to mitigate the chance of a DNS attack. And these are my references. Thank you.